Okay, so now we're going to talk about the tangent and the cotangent functions. Basically everything we talked about for the most part with the sine and the cosine transformations are very similar. Think of them the same. The difference is the period is different. The period for the tangent and the cotangent both is just pi. Okay, so don't get hung up on that. It's just half the period of the sine and cosine. So the period of both is just pi. So, you know, when you have one of those functions, actually that should be a minus, but you get the idea. What you want to do is you want to take this thing that you're taking the tangent of, and essentially with the tangent, you're going to want to put it in between negative pi over 2 and pi over 2, because that's the traditional domain of the what they call the base period for the tangent. So you put your bx plus c in here, and you'd solve to find out where does it start, where does it end. With the cotangent, it also has a period equal to pi, but it starts and ends at different places. So when you do this one, you want to set it up, you want to set this up from 0 to pi. Okay, from 0 to pi. And, you know, whatever, you know, bx plus c, whatever you've got in this function, that goes in there. You solve just like you did for sine and cosine, and you'll find your phase shift and everything else. Other than that, the only thing that changes is the shape of the graph. And what happens, these endpoints, whatever they become asymptote lines. And they have a periodicity to those asymptote lines that recur and recur. With the tangent, you'll have an asymptote line over here. You'll have another one over here, which will be the endpoints, whatever this resolves to once you solve for x in this equation. Again, you'll have to take care of your amplitude. We'll talk about that a little bit more later. This is probably the most important thing, your vertical shift up and down, because that's where your tangent line, and let's just pretend d is 0. Your tangent basically follows that asymptote up from negative infinity, curves through, and then goes up like that. And that's what the tangent function looks like. Okay, and if there's no phase shift, then, you know, this would be the y-axis, and this would be negative pi over 2, and this would be pi over 2. So that's all well and good. You'd have another one equal distant out here, and you'd just do the same shape right there. Cotangent looks almost identical, but basically you're going to have an asymptote line, whichever that ends up being, another asymptote line, wherever that ends up being. And it just basically, it's a vertical mirror, right? So you find your midpoint, and you come down, and it's similar to what you see in some cubic functions. You know, you can look at this. It doesn't have quite as dramatic, and it's maybe spread out a little more, but it's the same idea. And of course, they repeat. So, you know, there's going to be another one right in here somewhere, and there's going to be another one of these, you know, right next to it that kind of does something similar. Hopefully you can draw better than I do. And that's all there is. And in the tangent, you might be saying, well, you know, what effect does this amplitude, because obviously this goes to negative infinity, this goes to infinity. You don't really call that amplitude anymore when you're dealing with these graphs. What the effect of A has, if A is a large positive number, then it's basically going to smooth this out. It's going to have a steeper slope, right? And if A is, say, a number between negative 1/2 and negative 1 and 1, so it's a small fraction, it's going to have a little bit of effect of maybe flattening it out in the middle a little bit. You'd actually have to plot some points in there just to get a feel for that. This has a much Now, I don't want to say it's less pronounced because it can be pretty dramatic, but it's not the thing I would worry about on these graphs. The thing that you really want to get is, where are these asymptotes? Where's your phase shift? Your phase shift and your vertical shift. Get those right, and I would just, for the most part, especially if these things are fairly narrow, I would go ahead and just, kind of draw that in. If this is a large number, then go ahead and make it higher slope. If this is a small fraction, you maybe flatten it out just a little and you'll have it. Same thing with these. It's just a difference in how much it flattens out through the middle a little bit. If you want to experiment with a graphing calculator or an online graphing tool and see just how that A value affects some of these tangent and cotangent graphs, go right ahead, and it'll give you a feel for it, but probably not the thing you need to get hung up on when you're graphing the tangent and the cotangent. So again, you're going to use the same kind of skills. These things mean the same thing for the most part. Amplitude changes a little. This is still a phase or a vertical shift. Your phase shift and your period can be changed by B and C in exactly the same way that they were with the sine and the cosine. So at this point, you should have all the skills you need. I may do some more videos on some specific functions and graphing them. But other than that, you should be able to be successful at graphing trigonometric functions.